Hello, I am Ice Embalsado. Here is an answered question and three solved problems from Chapter 14 entitled Capital Structure and Leverage from Brigham and Houston's book, The Fundamentals of Financial Management, the 15th edition. If a firm goes from zero debt to successively higher levels of debt, why would you expect its stock price to rise first, then hit a peak, and then begin to decline? Tax benefit from debt increases linearly, which makes for a stable increase in the value and stock price of a firm. Financial distress increases as more debt is incurred, offsetting the costs and causing the decline of its previous benefits. Hartman Motors has $18 million in assets, which were financed with $6 million of debt and $12 million in equity. Hartman's beta is currently 1.2 and its tax rate is 35%. Use the Hamada equation to find the Hartman's unlevered beta. Here are the given. Debt is at 6 million, equity at 12 million, the levered beta is 1.3, and its tax rate is 35%. Using the Hamada equation, we have derived the formula to get the unlevered beta. With the formula for the unlevered beta and the given data, Hartman's unlevered beta is equal to 0.9811. Situational Software Co., or SSE, is trying to establish its optimal capital structure. Its current capital structure consists of 25% debt and 75% equity. However, the CEO believes that the firm should use more debt. The risk-free rate is 4%, the market risk premium is 5%, and the firm's tax rate is 40%. Currently, SSC's cost of equity is 12%, which is determined by the CAPM. What would be SSC's estimated cost of equity if it changed its capital structure to 40% debt and 60% equity? Here are the given data. Debt is at 25%, equity is at 75, its risk-free rate is at 4%, its risk premium is at 5, tax is at 40, and cost of equity is at 12%. We need to find the cost of equity if capital structure is at 40% debt and 60% equity. Using the formula for the cost of equity, we can now find the firm's current beta. The firm's current beta is 1.6. Next, we need to find the unlevered beta. The unlevered beta is equal to 1.33333. Since we now know the unlevered beta, we can now find the new levered beta. The new levered beta is equal to 1.866662. Since the new levered beta is known, we can now compute for the new cost of equity under the new capital structure. The cost of equity is equal to the risk-free rate added to the risk premium multiplied by the levered beta. The new cost of equity is 13.33331, which means that the cost of equity has increased from 12 to 13.33%.